Ionization energy. Today we'll discuss in detail the term first ionization energy. As we discussed, it is energy required to remove electron from a neutral gaseous atom. It should be an atom and it should be in a gaseous state. And how much energy is required to remove that electron from that neutral gaseous atom, we call that as ionization energy. And that's when we remove the first electron, we call that as first ionization energy. Same way, already we remove one of the electron and we are removing the second electron, then it is refers to second ionization energy. The general trend of ionization energy, as we go down the group, because the size increase, so ionization energy decreases. So down the group, the ionization energy is decreasing. Across the period, the ionization energy increases. So factors that are affecting the ionization energy. Number one, there are three main factors. The attraction of the nucleus, the more proton in the nucleus, the greater the attraction, so higher ionization energy. Like example, if we compare the ionization energy of sodium, sodium is Na, which is 11 and 23. And magnesium, 12 and 24. When we draw the structure for sodium, the nucleus of a sodium, it will have 11 protons. But when we draw the nucleus of magnesium, it will have 12 protons. And here the attraction, because when we draw the structure, so for sodium first, second and third shell, first shell it will have 2 electrons, second shell it will have 8 electrons, and third shell it will have 1. For magnesium, first shell 2, second shell 8 will be there, and the last shell 2 electrons. So you can see here 12 protons are attracting the electron in the third shell, and here 11 protons are attracting the electron in the third shell. So which one will have higher ionization energy, sodium or magnesium? Which one have a greater attraction from the nucleus or experience a greater attraction from the nucleus? So magnesium will have a greater attraction towards the nucleus. That's why ionization energy of magnesium will be higher. So first factor depend is attraction of the nucleus. Second factor, distance of electron from the nucleus. Like as the number of the shell increases, the distance between the electron and the nucleus increases as well. So ionization energy will decrease. So example, you have two different elements which are having different numbers of shells. Element 1 is having 2 shells, but element 3 is having 3 shells. So as you can see, electron in the second shell will be closer to the nucleus, where as compared to electron in the third shell. So which one have a higher ionization energy? A will have higher ionization energy compared to that of B. So the reason, because greater distance between the nucleus and electron, so weak attraction, small amount of energy can remove this electron out from the atom. The third factor depends on the shielding effect. Shielding effect means how many inner shell electrons are there. That's also refers to shielding effect. So for example, if we are talking about this electron, so for this electron, how many inner shell electrons are there? 1 and 2. Because electrons are like charges repel. So this will have weak repulsion. But when you check B, it will have more inner shell electrons, or more electrons are there inside the shell. So greater the number of electron, greater the repulsion, and greater the repulsion, greater the shielding effect. So higher shielding effect means lower ionization energy. So shielding effect of attraction of the nucleus, as an electron in the outer shell is repelled by the electron in the inner shell, which weaken the force of attraction from the nucleus. So that's why the ionization energy. Higher shielding effect means lower ionization energy. So attraction of the nucleus, it is directly proportional to ionization energy. Stronger attraction, more ionization. Distance from the nucleus and ionization energy are inversely proportional, and greater shielding effect, smaller ionization energy, also inversely proportional. So using this concept, we can work out the structure of an atom. How we can work out the structure of an atom? Example, so we have sodium, which is Na11 and 23. So when we write the electronic configuration, 1s2, 2s2, 2p6, 3s1. This is how the 11 electrons are arranged. So when we sketch a graph for removing the electron and log of ionization energy, why we use log of ionization energy, not directly ionization energy? Because when the values have too much variation, like too much difference between the values, one of the value, example 400, another value is say example 4000, another value is say 50,000, another value is 100,000. So I cannot plot a graph using these values because it's difficult that I cannot have on the same scale 400 and 100,000. That's why we normally, when the values have a greater variation, we normally take a log and then plot the results. So if we plot the result for logarithm, the purpose of taking a log is to reduce the value. So if you plot a graph for logarithm and number of electrons removed, so because there are 11 electrons, so we should remove 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Now what happened whenever we remove the electron is always removed from the last shell. So which electron will remove first? We'll remove electron from 3s because that's the outer shell. So when the electron is removed from 3s, example, this was the energy. This is just an example. Then the second electron is removed from 2p. You can see here, this is the electron removed from third shell, and the second electron is removed from the second shell, and second shell is closer compared to that of third shell. So there will be a greater difference between the first ionization energy and the second ionization. Why there is a greater difference between first and second ionization? Because you remove the electron. This was a nucleus of the sodium and it contained 3 shells. So first electron you remove from the third shell, but the second electron is removed from the second shell, which are closer to nucleus, so required greater amount of energy. So whenever there is a change in the orbital or a shell, there is a greater jump between the ionization energy. Then you remove another electron. So another electron you also remove from 2p because there are 6 electrons. So you remove another electron from 2p, then you remove another until you remove all of the 6 electrons which are present in 2p. So, but what happened, because you are removing the electron from the same shell, so they will have a gap, but very small difference in ionization. So means when you plot the 6 electrons which you remove, so there will be a gap, but small difference as compared to the first and second. Why first and second? There's a big difference between the ionization energy Reason for that, because the shell changes. And then you remove electron from 2s. So 2s also orbital change, but the shell remain the same. So there again, it will be in the same order. Then again, when you remove the last electrons, last two electrons you're removing from the inner shell, then again there will be a big jump when you remove the 10th and the 11th electron. So the gap, big jumps are representing that there is a change in the shell. So here also what happened? The shell changes. Is it clear? So using this ionization or successive ionization energy, we can work out the atomic structure and identify how many shells are there in an atom. How many electron shells are occupied in an atom. Is it clear, the idea? Any doubt in this? The successive ionization energy of the element? Same way, if instead of sodium, if you was having aluminium, so if you have aluminium, which is 27 and 13, so when you write electronic configuration, it will be 1s2, 2s2, 2p6, 3s2, 3p1. But when you remove electron, the electron is always removed from the last shell. So the first electron which is removed is from 3p. So on x-axis, you have number of electron removed. And in y-axis, you have log of ionization. Why, again, I repeat, why we take a log? Because there is a greater difference between the ionization energy. Too much difference is there. So on logarithm scale, it reduces the difference between the values. So you want to remove 13 electrons. What is a log? Actually, log is a mathematical function which is used to reduce the value. Like example, if you have 4,000, okay, if you have 40, say 400, you have 14,000, you have 25,000. It will be difficult to plot these values on the same grid. So normally we take a log of the value to reduce the number. So when you take log 400, what's the answer of log 400? You have calculator, you can, what's the answer for log 400? $2.6. Then what is the answer of log 1400? Log 4,000, 1,400. It's 3. Then what is the answer for log 25,000? Log, which is about 4.4. So you can see here These numbers can be plot on the same grid because 2.6, 3, 4, but these numbers 400, 1,400, 25,000, it will be difficult to plot on the same scale. That's why we take a log, reduce the value, and then plot the result with log. So is it clear the concept of the log? It's just a mathematical function which is used to reduce the value. Now what happened as we remove the electron? So the first electron which is removed, the first electron which we remove is from 3p. So first we remove from 3p. So when we remove the electron from 3p, example, this is a value. Then the second electron, it is removed, then electron is in 3s. So there will be a gap, but not too much difference will be there between them. 3s, then 3s. Because 2 electrons are there. Then you remove the fourth electron. The fourth electron must be removed from 2p. So the shell changes. Whenever the shell changes, you will have a greater difference or a big gap or a jump between the ionization energy. And then you will remove from 2p. There are 6 electrons, so 6 times you'll remove electron from 2p. And then you remove from 2s and 2s. So 1, 2p, 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 and 2p. And then you remove electron from 2s. There will be a gap, but not too big difference. And then you remove from 1s. So the moment you remove electron from 1s, again, what you will have a greater jump. So how you can identify the jump shows that there's a change in the shell. Using this, you can identify the group and the number of the shells you used. So you can identify because there's a big jump after 3, so it belongs to group 3. After completing a topic, we'll do some topic-wise papers, questions, so you will have a better understanding of this. Any doubt till now? Is it clear the concept of ionization energy and why there's a gap or the jump? So here you can see first ionization energy linked to electronic structure. These are the 4 electrons removed. Then you observe a jump. So when you observe a jump, you can identify that there's a greater jump between the 4th and the 5th. So which group this element belongs to? This element belongs to group 4. Why it belongs to group 4? Because the electrons which are removed, are removed from the last shell. So this is a number of electron in the last shell. So you're removing 4 electrons from last shell. That's why it is group 4. And you can see 590 approximately. This is double 1100, 4500 and 4940, then 6400. And then when you will find a big jump between them, so just shows a greater difference is there between them. So shows that the shell changes. Whenever there's a change in the shell, you can identify the number of electrons from the last shell. Using this, you can predict the group of that element. If it is double or less than double, it is same shell. But if it is more than, like the increase, when you check this increase in value, if for example, if this value was 18,000, so you can see double of this is 12,000, but this is approximately 18. This is not 8,000, this is 18,000. So there's a greater gap. That's why shows the number of electron in the last shell are 4. Then the first ionization energy, you have to learn this pattern, but it's not like only learning. You can understand this as well. How you can understand this pattern? Normally, what happened to ionization energy? As we go down the group, ionization energy decreases. As we move across the period, the ionization energy increases across the period. So, but why some abrupt changes are there? You can see this is not the correct, this is not following the order. Why they're not following the order? So you can understand with a simple concept. First period of a periodic table, we have hydrogen and helium. Hydrogen electronic configuration 1s1, helium electronic configuration 1s2. So it's having a complete shell and it's closer to the nucleus. The helium contains 2 protons. So 2 protons are attracting electron in the first shell, where hydrogen 1 proton is attracting electron in the first shell. So helium will have stronger force, and it has a complete shell. That's why the ionization energy of the helium will be more than hydrogen. That's why the highest value of the ionization energy for first ionization energy for the element is for helium. So this is for first period. Now elements of second period, when we take the elements of second period, what are the elements of second period? We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the elements in the second period. So as we move across the period, what is the journal trend? The journal trend, ionization energy increases, or ionization energy should increase. But what we observe that beryllium, boron is not following the same trend, as it should be higher, but boron is having a lower ionization energy than beryllium. And same thing, when we check oxygen, oxygen is having a lower ionization energy than nitrogen. So what is the reason why the beryllium and a boron having a different ionization? Like as we move across the period, the number of proton increase in the nucleus, so ionization energy should increase. But from moving from beryllium to boron, it should increase, but we observe it is decreasing. Same way, moving from nitrogen to oxygen, it should increase, but again we observe oxygen is not higher, it is decreasing. What's the reason for that? When you write the electronic configuration for beryllium, beryllium is 4 and 9, and boron is 5 and 11. So when you write the electronic configuration, it is 1s2, 2s2. But when you write for boron, it is 1s2, 2s2, 2p1. So for the last shell, this is the last shell. For the last shell electron, in case of beryllium, only 2 electrons in the inner shell. But in case of boron, there are 4 electrons in the inner shell. So which one have a greater shielding effect? Boron will have a greater shielding effect. So as it will have greater shielding effect, and I told you shielding effect and ionization energies are inversely proportional. So due to greater shielding effect, boron, even though there are more protons, but because there is a shielding effect, that's why it does not follow the same trend. It should be higher, but it's not higher. It does not follow the same trend because of shielding effect. So the difference why boron having a lower ionization energy than beryllium, even though it has more protons, but the reason is that because boron is having more inner shell orbital electrons, which result in a greater shielding effect, reduce the ionization energy. Is it clear why there's a gap difference between beryllium and boron? Is it clear, this idea? Then when you check between nitrogen and oxygen, why nitrogen and oxygen are not having the same or does not follow the same trend? So for that is related to the pairing of electron, like electron in a box model. So when we draw nitrogen is 7 and 14. So when we write electronic configuration, it is 1s2, 2s2, 2p3. So the electron in a box model for nitrogen, so first shell, it will have 2 electron, opposite spin. Second shell 2, and p is divided into, p is having consists of 3 orbitals. First, if we have 3 electron will occupy singly. So they have less repulsion. But when we write for oxygen, 8 and 16, so the electronic configuration 1s2, 2s2, 2p4. So when we make electron in a box model, so oxygen, this shell 2 electron, the second shell 2. But when you check the orbital p subshell, which is having 3 orbitals, so first electron will occupy singly, but there are 4 electrons, so then the electron will be pair. And because there's a pair of electron in the orbital, this pair will have more repulsion, so it will be easy to remove this electron out as compared to that of nitrogen. So that's the reason why oxygen ionization energy is less than nitrogen, because there's a pair of electron, so they have greater repulsion. A small amount of energy can remove this electron out from the shell. Is it clear, the two different reasons? And same way, if the question is what is the why magnesium and aluminum, so you can see that's the same reason. This is group 1, group 2, boron is group 3, carbon is group 4, nitrogen group 5, oxygen group 6, fluorine group 7, neon group 8. That's a period 2 and groups. And same way, group 1, group 2 is magnesium, group 3 is aluminum. So again, you will find group 2 and 3 from moving from group 2 to group 3 across the period, what we like moving across the period, and the group number will change, the period will remain same. So you will observe that 2 and 3, again, they have a gap. Why there's a gap? Again, in aluminum, it will have a greater shielding effect than magnesium. Then when you check group 4, phosphorus group 5, sulfur group 6. So you can see nitrogen was group 5, oxygen was group 6. Now phosphorus group 5 and sulfur group 6. What is the reason why phosphorus ionization energy is a bit higher or equal to sulfur? The same reason is because the same reason is there, because it will have a pair of electron in the orbital, so they will have greater repulsion. Due to this greater repulsion, electrons can be removed easily. Any doubt in this part? Is it clear? So you have to learn this trend, and it's easy to remember. Group 2 and 3, there will be a jump. Group 5 and 6, there will be a jump as well. So if a question is Why helium? The largest first ionization energy. What's the reason why helium is? Because helium contain two protons, contain two electron, neutron I'm not drawing just because it's a structure. So electrons are closer to the nucleus. So its first electron in the first shell, which are the closest to the nucleus, no shielding effect is there. So helium has a bigger first ionization energy than hydrogen, and which is having one proton. And then why do first ionization energy decreases down the group? So as we go down the group, what's the reason why the ionization energy is decreasing? Even though there are more protons, but what happens as you go down the group? The number of the shells changes, electron shells. So as we go down the group, the outer shell electron are far away from the nucleus. So further away from the nucleus, they will have greater shielding effect, because more inertial electron means greater shielding effect. This will have small shielding effect, and this will have no shielding effect. Is it clear? The two reasons why, if a question is why helium ionization energy is higher than other elements or hydrogen, you can be mentioned in terms of distance between the nucleus and electron and the shield, no shielding effect. And why do first ionization energy decreases down the group? Because greater number of shell, electrons are far away from the nucleus, and greater shielding effect. That's why they will have lower ionization energy. Then why is there a journal increases first ionization across? Generally, ionization energy increases across the period, but we observe like for group 2 and 3 element, on group 4, 5 and 6 element, it does not, but generally it increases. So what is the reason why it increases across? So as we move across the period, there are more protons. As a greater the number of the protons, greater attraction for the same shielding effect. Why same shielding effect? Because, like example, if we say, we discuss why sodium ionization energy is smaller as compared to magnesium, or magnesium is having higher. So when we draw the structure, the first shell it will have 2, both will have 2. The second shell both will have 8, and the third shell will have 1 electron in sodium and 2 electrons in magnesium. So what happened? The same third shell, but here third shell is experiencing attraction from 11 proton. Third shell electron experience attraction from 12 proton. So greater attraction for the same shielding effect. Why? Because same number of shells, so same shielding effect. Is it clear? Any doubt in this part? And if they ask why sodium has a much lower first ionization energy than of neon, so when you write for sodium, so sodium is having 3 shells, because sodium is 11, neon is 10 and 20, whereas sodium is 11 and 23. So in case of sodium, you're removing electron from 3s, the third shell, but where in case of neon, you're removing electron from second shell. So which one have a greater shielding effect, sodium or neon? Here you have 8 electrons, complete shell is there. Which one have a greater shielding effect, sodium or neon? Yeah, which one have a greater shielding effect? Shielding effect refers to number of electron in the inner shell. So in case of neon, only 2 electrons in the outer shell is there, last shell, and inner shell only 2 electron. But in case of sodium, the first shell is there and the second shell, which is having 8, so more inner shell electron, greater shielding effect. So greater shielding effect, uh, less attraction towards the nucleus. That's why the ionization energy for neon is higher as compared to that of sodium. The shielding effect for sodium is greater. Shielding effect means like when you leave the outer shell electron, ignore the outer shell electron and check how many electrons are there in inner shell. That decides the shielding effect. So if I leave the last shell, in case of sodium, means there are total 10 electrons. When I leave the last shell, in case of neon, only 2 electrons. So that's why neon is having a smaller shielding effect, where sodium is having a greater shielding effect. So why there's a small drop from magnesium to aluminum? So what's the reason why this is a small gap here? Magnesium and aluminum. So when we write the electronic configuration for magnesium, it's 1s2, 2s2. Magnesium is 12. So 1s2, 2s2, 2p6, 3s2. When we write for aluminum, it will be 1s2, 2s2, 2p6, 3s2, 3p1. So when you leave the last shell and check how many inner shell are there, electron. So here you can see 10 electron. Here in this case, you see 12 electron. So which one have a greater shielding effect? Aluminum will have a greater shielding effect. Higher shielding effect means lower ionization energy. So aluminum or last shell electron is in 3p, whereas magnesium it is in 3s. So electron in 3p shell are slightly easier to remove because higher energy or slightly shielding effect is there, or small shielding effect for 3s as compared to 3p. So ionization energy of aluminum will be smaller as compared to that of magnesium. Is it clear? Any doubt in this part?